This is CPE 233. This is the description of the first experiment. So first experiment actually has 4 parts. We're only doing one part. This is really important. We're only doing part D. Okay, so essentially it's a prime number generator. So on a button press here, what we're going to do is fill up a RAM with the first 32 prime numbers. So that's going to be, it's going to need a RAM of at least 32, that can hold at least 32 things, and the width is something you can decide upon. Certainly it has to hold those numbers. So essentially it's going to start off, the RAM is going to be empty, the display is going to be displaying zeros, and then once it fills the RAM up with numbers, it's going to display those prime numbers on the 7-segment display. So so a couple things here. I know this is going to be repetitious. Usually it's standard digital modules in here. You shouldn't have to be making weird one-off modules for any reason. There is a prime number check module, which is the key to this experiment. We'll talk more about that later. You certainly have to use that. One of the constraints is don't use mathematical operators anywhere except in the given modules like counters and the ripple carry adders. This is a big circuit. No, it's not that big, but it's controlled by a state machine. State machines should have no more than 10 states. Very important, it should be completely independent of the RAM size, which means the number of prime numbers that it's going to store. And don't use any memory in your state machine other than your state variables. And most importantly, there's some other details such as constraints in the experiment description. Be sure to go read that. So Canvas has a ton of Verilog resources. You should use those. There's standard hardware modules such as muxes and registers, etc., etc. There's also a memory module there, which is a single port RAM. It's a simple RAM. Essentially, I call it N by M, which means you describe the actual capacity of that thing. You should also start off with the state machine cheat sheet. There's actually a module out there that's a working state machine. I always start from that. I never write a state machine from scratch. There's also the 7-segment display module. It's quite functional. It has many options. All those options are described in the header of that module, so be sure to check that out. I'm hoping you've used this before in your 133 class. If not, it's not that big a deal. Just go check it out. This experiment has a new module, which is the prime number check module. Essentially, given an input, it will tell you if that input is prime or not. So basic approach to hardware design. One, before you do anything, you got to understand the problem. Once you understand the problem, you can start dropping down modules, such as, if you have to add something, obviously you're going to need a ripple carry adder, since that's the only way, roughly, we know how to add. So once you plop all the modules down, you're going to need to connect them, and then you're going to need to control them with a state machine. So once you got all the modules down there, the next step is to generate a state diagram. And finally, once you have all that laid out, the final step is to create Verilog models for everything and make it work. Generally speaking, a lot of the modules are provided. You're just dropping them down, gluing them together, providing a state machine, and making it work from there. So once again, this is like the approach again. Understand the problem. You always design it on paper. Make it really simple. This is not a complicated experiment. Don't try to be clever. Try to be simple. Lots of people try to make their state machine really clever with as few states as possible. There's plenty of states in here. This is not a time constraint, as in do it as fast as possible. Just get it done very simply. Now this is hardware design. It's an iterative process, meaning you're going to make a bunch of mistakes and go back and fix them, make a bunch of mistakes, go back and fix them. More importantly, as you're designing this, you're going to not see stuff, not realize stuff, you're going to have to go back and redesign it. It's expected. My motto is the hardware design process is not linear. It's actually kind of circular and iterative. So once again, when this is all done, test it on the Basis 3 board and take a picture, send me the video. Okay, so you got to ask questions. Don't get stuck on anything. Send me diagrams if you need to. Please make them as readable as possible. So like I said, most of the stuff is provided here. All the modules are on Canvas. The important thing is that a lot of the modules are generic, which means you got to override default values. So make sure you know how to override the default values and make sure you override them. Do not, I'm going to look for this, do not rewrite the modules. I want you to instantiate the modules and overwrite the defaults. If you don't do that, I will be unhappy. So all the modules need inputs, so inputs need to be tied to something, 1 or 0. The outputs can be hanging. You don't need to tie them to anything. You can just leave empty parentheses on those. The 7-segment display once again is provided. The prime number check module is provided. Templates provided. When you're testing this thing, it's really important. The prime number check module has a test input, which we'll talk about later. And if you're, when you're testing this on the simulator, you're going to have to lower the clock speeds on both the clock divider and also the module itself. So if you notice one of the clock dividers has the word testing in it, that's the one you want to use. It makes it really easy to change your clock speed on the state machine or in the whole circuit in general from really slow to really fast, because you want to remove all the clock dividers. So once again, when you're testing this, meaning simulating it, you want to have all the clock dividers removed, and I've done that as easily as possible on the clock divider and on the prime number check module itself. So this is your high-level diagram here. I actually have the LEDs written in there. You don't really need to put LEDs on there. It's a nice debug tool which you can use to show like the address of the RAM or so if you want to. So this is optional. These are required. Essentially what you're going to do is press that button and it's going to start filling up, looking for prime numbers and filling up the RAM with prime numbers. So this is your prime number generator, a prime number checker box, and the idea here is it's going to, you give it a number on this num input, and then you assert the start, and it's going to tell you whether that number is prime. So once you assert the start, the done will turn off, and then it'll take some time, and at a certain time later the done will turn back on. So the done will make a little diagram here. When the done turns back on and the prime turns back on, it's a prime number. Otherwise, if the prime remains 0, it's not a prime number. So what you want to look for is that done, turn on, and then handle it accordingly. Now this input here is the test input, and if you look at the directions here, if you assert this thing, like tie it to a 1, it removes the clock divider inside this number check module. So when you're testing it on the simulator, you want to assert this test input, which means make it a 1. And when you're using it on the board, of course, you want to make that a 0. So the due date it's 3 clock periods from today. 3 clock periods, 3 class meetings, and I know we don't have clock meetings. Class meetings, not clock meetings. The idea is that's when it's technically due, but really I don't have due dates. The idea is if you don't turn it in by next Monday, you are behind. Now I know this is not the world's easiest experiment. I know I'm hoping that your 133 prepared you for this. If not, you're going to have to work on it and ask questions. The due dates are flexible. but I don't want you to fall behind. If you fall behind, it's just nearly impossible to catch up, so don't fall behind. The important thing here is for the due dates, the next experiment's much easier. So I would say throw some time at this and get it done, and then the next one will be not quite as bad. And that is it. Most importantly, go read the description in the lab manual, the lab activity manual. There's some more notes in there that will help you out and describe some more of the requirements, such as what to turn in. There's a list of deliverables, and be aware that if deliverables are not delivered in a manageable and readable fashion, I'll bounce it back to you and ask you to resubmit.